Now it's BCT.
And that's a comparison test, as it says. You have to compare to either a P series, because we know how they behave, or a geometric series, because we know how they behave right away. So you compare it to something that you know of. Okay, you cannot compare it to something that you don't have any idea. So for example, when do I use BCT or LCT? When I have rational series or series that look geometric but are not, okay? Have some geometric terms that look geometric, or series that look like P series. So rational series, they look like P series, but they're not. So this is where I would use the BCT or LCT, same thing. But BCT, you know, be careful when you compare summation AN and summation BN. Okay. If BN converges, then summation AN converges. So you have two cases. If summation BN converges, then summation AN converges. So this is what you compare it to. And if summation AN diverges, then summation BN diverges. So the second case, you compare it with AN. You know BN is given to you, you compare with some AN. The first case, AN is given to you, you find some BN to compare it to. So for example, I'll give you both examples here.
Now A sub n has to always be less than B of base B of n, right?
Well, it depends on what you have actually. But
yeah, I've never got that. I don't know.
It's only going to affect the other one if one's bigger or smaller.
Yeah, one of them, that's what you're given. The problem is either summation AN is given or summation BN is given in the problem. Okay. So it does, you know, for this one right here, the AN is given to you. So you have to find that BN. The second one, the BN is given, you have to find that AN. So you just have to remember this. Well, it doesn't matter which one is given. But if one is smaller than the other, if this one converges, this one converges. If this one diverges, this one diverges. That's how it goes. I'll try to give you both examples.
Okay, I see.
We have, let's do this one, 1 over n squared plus 4. Okay? So what do I compare this with?
1 over n squared.
1 over n squared. Okay? So you see, this is what I'm given, I compare it with this one. So I don't care which one is AN or BN. I just need to make that comparison. Okay. So n squared plus 4 is bigger than n squared. So 1 over n squared plus 4 will be
Smaller.
less than n squared. You see, this is what I need to have, period. So summation 1 over n squared plus 4 is less than summation 1 over n squared. This is what I know. I know about this one. I know this one converges. And that's the case 1, as you can see. If the bigger one converges, I know that the smaller one converges. So since summation 1 over n squared converges, then of course this one has to converge.
It's like forcing.
Okay?
But if that n squared was n to the 1/2, then it would,
If this was n to the 1/2 here,
yeah.
then this would be the same thing. The n to the 1/2, it diverges though. I cannot say anything.
So I mean, you can't because it's
Yeah,
big.
you can. So
Because
you have
it's
to use
not.
LC.
Yeah.
Okay. Because if this one diverges, I cannot say anything. This one has to converge and I can conclude.
Yeah.
Or this one has to diverge and I can conclude.
So basically, you've got to find the frame of reference between the two,
Yes.
and then if the frame of reference, if the whichever you end up finding for the what you're comparing it to, if the frame of reference will affect the other one.
Yes. So
Right.
either this way, converge this way, or diverge that way.
But it has to be on the one side for it to actually affect it. Because if it's not on that side, then you need to look
Then
at
you
it.
can't.
Yeah, then you have to look LCT.
Yes.